And welcome back again. So now we're going to look at going into basin D, catch basin D. And for that, we have to figure out what the Q is going to be. Once again, Q is equal to CIA. We have our 0.4, we have our acres. Wow, it was really nice. I gave everything. Okay, made this one a little bit too easy. I'll make up for that later. Times 3 inches per hour. I'm smiling if you can't see me. 3.2 acres. Q would then be 0.4 times 3 times 3.2. 3.84 CFS. So that's what's going into this basin. We have coming in here 3.84 CFS plus we have some water from above, 15.82 coming in, which means coming out we have a Q total of 3.84 plus 15, 15.82. 19.66 CFS. Okay, get some good water flow through here. What did I tell you about this one? Oh, that's right. Here's where I make up for it. I didn't tell you anything about this pipe. Anything goes. All right, so go ahead and design the pipe. You can pick your velocity, your diameter, your slope. The only thing you have to do is make sure it handles at least 19.66 CFS. So pause it, try it on the nomograph. Well, try it on the nomograph first, see what you come up with, and then we'll talk about the different options, and then we'll go through the actual calculations later on. So give it a pause and try the nomograph. Okay, welcome back. So when you're given an unlimited number of options, let me just show you where you have to be. If you chose a diameter anywhere between, I want a straight line. Let's see. Between there and there, I'll refine this just a little bit. $20 and $8. Okay, so basically, any diameter in this range would be an acceptable solution. So you could choose a 24, a 27, a 30, 33, 36, 39, or 42. Any of those would work to make that pipe flow properly. But what's really the best option? And best is a relative term. What I would have done, or what I'm going to do, is I would probably look to maybe go with the 24-inch diameter pipe. And the reason why is once you make a pipe a certain size, you cannot go any smaller than that. You can always go bigger, but downstream the pipes have to be the same size or larger going downstream. You cannot make the pipes any smaller, otherwise it creates a bottleneck and you get things backing up. The water backs up as you flow through it. But that may not be the best option, and I'll show you why. So, that's not going to work. Let's try blue line here. Nope. Okay. And again, I'm talking this out as we go through it because I want you to understand what's going through my mind. Okay, so 24-inch diameter pipe. You know what? I am going to use that because the velocity is about 6.5. That's not too bad. I thought when I first looked at it, I thought it was going to be a little bit faster. So I think that's good. We'll use a 24-inch diameter pipe. If it went to a 27, it's going to start slowing into that 5 5 foot per second range, which is also good. I definitely wouldn't go up to like a 36-inch diameter because two things. The water's going to run on the slower side, but 36 inches is a pretty big pipe. It's going to get, that's a big jump in the amount of material that has to get handled and the overall cost to it. So it looks like my slope is 0.0080. So based on that, let's see what we calculate. Diameter will be 24 inches. We have a Q of 19.66, we said. We can match it perfect. Okay, so find the slope and find the velocity. Is that right? Yeah, okay. Which comes first? Well, we've always been doing the Manning equations. Let's go with that first. So V is equal to 1.486 R to the 2/3 S to the 1/2 over N. So as I start solving for S, slope is equal to Vn over 1.486 R to the 2/3 squared. And when I start going to plug in my numbers, we're missing V. Okay, so we can't solve this. We have hydraulic radius, we have N, we can't solve it. So how do we get our velocity? Don't forget your other equation, Q equals AV. It's such a simple equation, but it really helps to solve a lot of these problems. So 19.66 CFS, that's a horrible F. Let's see, 2 squared pi over 4 times velocity. So velocity will be equal to 19.66 CFS. Divide, this is going to cancel out, divide by pi. Divide by pi, 6.25. Now I can plug it in there. Let me go back to red. Slope is equal to 6.25 times 0.013 over 1.486, 2 over 4 to the 2/3 squared. Again, pause the video, do the math on there, and then see if you match what I get. So I'm gonna, while you're pausing it, I'm gonna do the math. Okay, slope is 0.0075. And I don't know if that was even close. Okay, 0.008. We're close. What I'm looking for is I want to make sure I'm not off by a factor of 10, where I'm getting a slope of 0.075. That would be a big mistake. If you're off, a thousandth or so of a percent, we're in a the right ballpark where we need to be with that. Okay. So great, we're designing these pipes as we go. So we only have one more pipe to go. So let me end this video and then we'll take a look at pipe EF.